Alright, let's talk about something insane. You and I, we breathe air. It's easy, we don't even think about it. But imagine trying to breathe underwater. You can't. You'd last maybe a minute, maybe two if you're a pro. But fish live their entire lives down there. They are masters of an environment that would literally be the end of us in minutes. Breathing underwater isn't just a neat trick, it's one of the most incredible survival hacks in the entire animal kingdom. It is a full-on 24/7 challenge that fish have absolutely conquered. And today we are going to break down exactly how they pull off this unbelievable feat. So why is it so hard? Well, water has way less oxygen than air. Like, it's not even close. For every million parts of water there are only about 5 to 10 parts of oxygen. Air, on the other hand, is packed with over 200,000 parts of oxygen per million. That means a fish has to work thousands of times harder than we do just to get the same amount of life-giving oxygen. It's like trying to get rich by picking up single pennies off the street while we get to walk into a bank vault. This is the ultimate underdog story, and fish are the undisputed champions of this underwater world. This whole process is called respiration, and it's what keeps every living thing, including fish, powered up. There are two parts to this. The first is internal respiration, which happens inside every single cell. Think of it like a tiny engine in your body that uses oxygen to burn food for energy. But the really epic part, the part we're focusing on today, is external respiration. This is the big step, getting the oxygen from the outside world, the body, in the first place. For us, it's breathing air into our lungs. For fish, it's pulling that super scarce oxygen directly out of the water. And that is where our story truly begins. Fish don't have lungs. Instead, they have something even cooler, something engineered to perfection for their underwater life. They have gills. These aren't just simple flaps on the side of their head. They are high-tech, biological machines that make the impossible possible. Gills are the reason fish can swim, eat, and survive in the deep. They are the absolute key to life underwater, a masterpiece of evolution that allows them to thrive in a world we can only visit. So get ready, because we're about to dive deep into the mind-blowing world of gills. So what exactly are gills? Forget everything you think you know. Gills are not just slits on a fish's face. They are the fish's ultimate superpower, their personal scuba gear, and their life support system all rolled into one. Located on either side of the head, these amazing organs are protected by a tough bony flap called the operculum. Think of the operculum as a shield, guarding the delicate and incredibly important machinery hidden underneath. When a fish opens and closes its mouth, it's not just yawning, it's actively operating its breathing apparatus, pulling water in and pushing it over these amazing structures. Here's a crazy fact for you. If you could take out all the tiny feathery parts of a fish's gills and lay them out flat, the total surface area would be massive. For some active fish, the surface area of their gills can be 10 times larger than the entire surface area of their body. That's like having lungs the size of a parachute packed inside your chest. This huge area is absolutely critical. Remember how little oxygen there is in water? Well, the fish needs as much contact with that water as possible to grab every single molecule of oxygen it can find. More surface area equals more opportunity to breathe. Gills are basically a massive, folded-up net designed to catch oxygen. As water flows over them, these structures act like a superfine filter, but instead of catching dirt, they catch life itself. The design is so efficient, so perfectly tuned, that a fish can extract up to 80% of the available oxygen from the water that passes over its gills. For comparison, our lungs are way less efficient. We only pull about 25% of the oxygen out of the air we inhale. Fish are literally 4 times more effective at breathing in their environment than we are in ours. That is an insane level of performance. So, when you see a fish in a tank just chilling, remember what's happening under that gill cover. It's a constant, high-stakes operation. The fish is performing a biological miracle every second of every day. Gills are the difference between life and death in the underwater world. They are more than just a body part. They are a testament to millions of years of evolution, creating the perfect tool for survival in an extreme environment. They are without a doubt one of the most incredible adaptations on the entire planet, and we're about to see how they work. Let's crack open the hood and look at the engine. What makes gills so powerful? It's not just one single part, it's a team of specialized components working together in perfect harmony. The whole system is built on a set of structures called gill arches. These are hard, bony loops that provide the main support for everything else. Think of them as the foundation of a skyscraper. You get 4 or 5 of these arches on each side of the fish's head, and they are the strong backbone that holds the entire breathing factory together, ensuring it can withstand the constant pressure of water flowing past. Attached to these arches are the real superstars of the show, the gill filaments. These are the delicate, feathery tissues that you see when you look at gills. They are bright red for a very important reason. They are absolutely packed with blood. Each gill arch has 2 rows of these filaments sticking out like the teeth on a comb. This arrangement is designed to maximize their exposure to the water. The filaments are where the magic happens, where oxygen from the water actually passes into the fish's bloodstream. They are the front line, the place where the outside world meets the inside of the fish, but that's not all. On the other side of the gill arch, facing inward towards the fish's mouth, are the gill rakers. These are bony, finger-like projections that act like a bouncer at a club. Their job is to protect the delicate filaments from getting damaged. As the fish gulps down water, food, or even sand and debris, the gill rakers act as a filter. They catch any big particles and stop them from flowing over and tearing up the fragile filaments. In some fish that eat tiny plankton, these rakers are super fine and act like a net to help them catch their dinner while they breathe. So you have the arches for support, the filaments for breathing, and the rakers for protection. It's an incredible 3-part system that makes the whole operation possible. Each part has a specific job, and they all have to work perfectly together. The gill arches provide the strength, the rakers provide the safety, and the filaments do the all-important work of capturing oxygen. This isn't just a random collection of parts, it's a highly sophisticated biological machine that has been fine-tuned over millions of years for maximum efficiency and survival. It's truly a power factory. Okay, so we have these amazing gills, but they are completely useless if water isn't moving over them. A fish can't just sit there and hope oxygen bumps into it. It needs a constant, fresh supply of water flowing over those filaments 24/7. To do this, most fish have developed an incredible 2-part pumping system. It's a machine that never stops, working day and night to keep the fish alive. It involves a coordinated dance between the fish's mouth and its operculum, the protective gill cover. This system is known as buccal pumping, and it's absolutely genius. Here's how the cycle works. First, the fish opens its mouth and lowers the floor of its mouth. This makes the inside of its mouth bigger, which creates suction and pulls water in, just like pulling back the plunger on a syringe. At this exact moment, the operculum on the side of its head is clamped shut. This ensures that water can only come in through the mouth and doesn't leak out the sides. The fish has now successfully loaded its mouth with a fresh gulp of oxygen-rich water. Step 1 is complete. The chamber is loaded and ready for the next phase. Next, the fish closes its mouth. This action shrinks the space inside its mouth, which pressurizes the water that's trapped inside. Now, with the mouth sealed shut, the water has nowhere to go. But then, the fish opens its operculum. The pressurized water rushes out, flowing directly over the gill filaments in a strong, steady stream. As this water rushes past, the filaments get to work, pulling all the oxygen out. This cycle repeats over and over again without a single break. Open mouth, close operculum, pull water in, close mouth, open operculum, push water out. This pumping action is a masterpiece of biological engineering. It guarantees that water is always flowing in one direction, in through the mouth and out over the gills. This one-way flow is incredibly important for making sure the fish can extract oxygen efficiently. It's like a perfectly designed plumbing system that never gets clogged and never flows backward. For many fish, this is how they spend their entire lives. Pump, breathe, pump, breathe. It's a relentless, life-sustaining rhythm that powers their journey through the underwater world. It is their non-stop engine of life. While many fish are using that awesome pumping machine to breathe, some of the fastest, most powerful fish in the ocean use a different strategy. And honestly, it is absolutely epic. This strategy is called ram ventilation, and it's basically the underwater equivalent of a jet engine. Fish that use this method are the sports cars of the sea. Think of sharks, tuna, and swordfish. These are animals built for speed, and their breathing method is perfectly matched to their high-octane lifestyle. They don't have time to sit around pumping water. They are constantly on the move, and they use that movement to their advantage. So how does it work? Well, it's brilliantly simple. Instead of pumping, a fish using ram ventilation just swims forward with its mouth wide open. As it powers through the water, the sheer force of its movement rams a massive amount of water into its mouth and straight over its gills. This creates a continuous high-pressure flow of water over the filaments. The faster the fish swims, the more water is forced over its gills and the more oxygen it can absorb. It's an incredibly efficient way to breathe, but it comes with one massive catch. They can never ever stop swimming, that's right. For many sharks and for powerful fish like tuna, stopping means death. If they stop moving forward, the water stops flowing over their gills, and they essentially begin to suffocate. They are trapped in a perpetual state of motion, destined to swim for their entire lives. This is why you will never see a great white shark just chilling at the bottom of the ocean. They are always cruising, always moving, always forcing that life-giving water over their gills. Their survival is directly tied to their forward momentum. It's the ultimate commitment to a life of speed. Now this method isn't for every fish, of course. It only works for animals that are strong swimmers and spend most of their time cruising at high speeds. It's a specialist tool, a high-performance system for elite ocean athletes. Ram ventilation allows these predators to get the huge amounts of oxygen they need to power their massive muscles, letting them chase down prey and travel vast distances across the ocean. It's a perfect example of how evolution shapes an animal's body and behavior to perfectly match its environment and its needs. It is honestly the definition of living life in the fast lane. We've seen how fish breathe when everything is perfect, but what happens when it's not? What happens when the oxygen levels in the water plummet? This is a real and constant danger for fish all over the world. This condition, called hypoxia, can be caused by many things: hot weather that makes it hard for water to hold oxygen, pollution from factories, or algal blooms that consume all the oxygen at night. When this happens, the fish's amazing breathing system is pushed to its absolute limit. It becomes a frantic, desperate fight for survival. When a fish senses that oxygen is low, its body goes into emergency mode. The first thing it does is start breathing faster and deeper. You can actually see this happen. The fish will start pumping its mouth and gills much more rapidly, trying to force as much water as possible over its filaments to grab every last available molecule of oxygen. It's the fish equivalent of you gasping for air. At the same time, its heart rate will increase, pumping blood faster around its body to deliver the little oxygen it has to its vital organs. It's a full-on panic response. If the oxygen levels get critically low, the fish has to take even more drastic measures. Many fish will swim to the very surface of the water and start gulping at the air. This is called aquatic surface respiration. They are trying to breathe the thin, oxygen-rich layer of water right at the surface, or in some cases even trying to gulp air directly. You might see this in a pond on a hot summer day. It's a clear sign that the fish are in serious trouble and are struggling to breathe. They are literally fighting for their lives at the boundary between their world and ours. But if the oxygen doesn't return, even these desperate measures will fail. The fish's cells, starved of the oxygen they need to function, will start to shut down. The fish will become lethargic, unable to swim or even stay upright. Eventually, its life support systems will fail completely, leading to death. This is why pollution and climate change are so dangerous for aquatic life. By lowering oxygen levels in the water, we are essentially suffocating the fish in their own homes. It's a silent and invisible crisis, a survival test that millions of fish are failing every year. We've talked about the big parts of the gill, but now we have to zoom in, way in, to see the real secret to their incredible efficiency. The magic is in the fine details of the gill filaments. Each filament is covered in even smaller, flap-like structures called lamellae. These are microscopic, leaf-like plates that are lined up like tiny pages in a book. This is where the gas exchange actually happens, and their structure is pure genius. There are thousands of these lamellae on every single filament, creating a truly massive surface area for absorbing oxygen. But here is where the real mind-blowing trick comes in. It's a process called countercurrent exchange. This sounds complicated, but we are going to make it super simple. Imagine two crowds of people walking past each other in a hallway, giving high fives. If they walk in the same direction, the people at the front can high five, but then it's over. But if they walk in opposite directions, everyone gets a chance to high five someone new as they pass. This is exactly what happens in the fish's gills, but instead of people, it's blood and water. Inside each lamella, the fish's blood flows in one direction. The water, meanwhile, is being pumped over the outside of the lamella in the opposite direction. This is countercurrent flow. As the water flows past, the blood inside the lamella is always meeting fresher water with a higher concentration of oxygen. Think about it. The blood that is just entering the lamella, which has very little oxygen, meets the water that is just about to leave, which has also given up most of its oxygen. But it still has more oxygen than the blood, so some oxygen moves across. As the blood continues to flow, now with a little more oxygen, it meets water that has a little more oxygen, and so on. All the way along the lamella, the blood keeps meeting water that has a slightly higher oxygen concentration than it does. This creates a constant oxygen gradient, a continuous downhill slope for oxygen to travel from the water into the blood. This secret high-five system is so incredibly efficient that it allows the fish to pull over 80% of the oxygen out of the water. Without countercurrent flow, they'd be lucky to get half of that. It is the ultimate biological hack. So, the fish has done the impossible. It has pulled oxygen out of the water and into its blood. But now what? That oxygen is useless if it just sits in the gills. It needs to be delivered to every single cell in the fish's body, from its brain to its tail fin. This is where another hero of our story comes in: hemoglobin. Hemoglobin is a special protein found inside red blood cells, and its only job is to be an oxygen delivery truck. It is the Uber Eats for oxygen, picking it up at the gills and dropping it off wherever it's needed. Think of each red blood cell as a tiny delivery van, and hemoglobin as the driver and cargo space combined. As the red blood cells flow through the super-thin capillaries of the gill lamellae, the hemoglobin inside them acts like a magnet for oxygen. It grabs onto the oxygen molecules that have just diffused from the water, locking them in for the ride. This is what gives blood its red color. When hemoglobin is loaded up with oxygen, it turns bright red. Oxygen-poor blood, on the other hand, is a much darker, purplish red. Once loaded up, these red blood cells travel away from the gills and are pumped by the heart all around the body. When the delivery van, the red blood cell, reaches a part of the body that needs energy, like a muscle, it finds an area where the oxygen level is low. This signals the hemoglobin to release its cargo. The oxygen molecules pop off the hemoglobin, pass out of the blood, and go straight into the cells where they can be used to burn fuel and create energy. The now empty red blood cell then continues its journey back to the gills to pick up another load. This delivery system is happening billions of times a second inside every fish. It's a non-stop, perfectly organized logistics network. The efficiency of a fish's hemoglobin can even be adapted to its environment. For example, a fish living in a fast-flowing, oxygen-rich river might have hemoglobin that grabs and releases oxygen very quickly. But a fish living in a muddy, oxygen-poor pond might have a special type of hemoglobin that is super sticky, able to grab onto oxygen even when there's very little of it available. It's another layer of incredible adaptation for underwater survival. So we've been on an absolutely epic journey. We've seen that breathing underwater is one of nature's greatest challenges. We've explored the fish's power factory, the gills, with their arches, rakers, and massive surface area of filaments. We've uncovered the secret of the non-stop pumping machine and the high-speed ram ventilation used by the sports cars of the sea. We dove deep into the microscopic world to witness the magic of countercurrent flow, the secret high five that makes fish breathing so unbelievably efficient. And we saw how the hemoglobin delivery service carries that precious oxygen to every part of the fish. It's clear that fish are the ultimate underwater survivors. Every part of their respiratory system, from the shape of their mouth to the chemistry of their blood, has been perfectly sculpted by evolution to conquer a world that is hostile to air breathers like us. They have solved a problem that seems impossible, and they do it every second of their lives without ever stopping. Their gills are not just an accessory, they are the absolute engine of their existence, the key that unlocks the vast blue parts of our planet for them to live in. So, what would happen if this incredible system failed? Imagine a fish's gills suddenly stopped working. It would be catastrophic and immediate. Within seconds, the oxygen supply to its blood would be cut off. The hemoglobin delivery trucks would return empty. The fish's cells, starved of the fuel they need to function, would start to shut down. The brain would fail, the muscles would cease, and the heart would stop beating. Within minutes, the fish would die. It's a stark reminder of just how critical and how constantly active this system is. There are no breaks and no holidays for gills. This is why we have to care. The health of our planet's water is directly linked to the survival of these amazing creatures. Pollution that clogs their gills or climate change that robs the water of oxygen is a direct attack on their ability to breathe. By understanding the incredible, complex, and fragile system that keeps a fish alive, we can better understand how important it is to protect their homes. Every fish swimming in every river, lake, and ocean is a living miracle of adaptation. They are true champions of survival, and their gills are the proof.